Okay, logarithms, kind of one of my favorite sections because we finally get our self an inverse for exponential. First of all, I want to talk about the number e, or the looks like a letter. Well, it actually is a letter, but it's a lowercase e, and in math, it's actually kind of like a number like pi. And by pi, I mean pi is the symbol that stands for 3.14. E is the symbol that stands for, it's called Euler's number. It's the approximation of is about 2.718, and it's often used in exponential problems where the growth is continuous. So, like for example, e to the third will get you an actual number. E to the negative second will get you an actual number. It's going to actually be that. And you can do that in your calculator. I don't have one with me. But the idea is if you have compounding continuous interest, so let's say I've got $5,000 and want to invest it in a bank account that calculates interest continuously. The APR is 3.2%. So I'll convert that to a percent into a decimal. That's what it would be. How much would be in the account at 5 years? So A equals my principal, $5,000. E again is a number, so that would be 2.71 is what you plug into there, and your rate of 0.032 times the time of 5. So again, that I don't have a calculator, you can figure that out, and that's how you use the letter E. And it will show up here with the logarithms too. My question I always propose to class is, I know 10 to the second is 100. I know 10 to the third is 1,000. So 10 to what power is going to give you 500? Well, I know it's got to be somewhere between 2 and 3 because 500 is between 100 and 1,000. So I kind of know this. But instead of guessing and checking, I'm going to show you an operation that you could use eventually to solve that and get the actual number for that value of x. So a logarithm. So here's kind of the idea. It's kind of radical or crazy to begin with, but notice that this b here, that's your base, just like if it was an exponential, that's also my base. Okay, here is the exponent. In a log, what it's equal to is the exponent. So whenever you're evaluating a log, you're actually trying to find the exponent that really solves or completes that problem right over there. And then y would be the number that this expression is equal to. Y is going to show up just after the log. So like here, kind of do the circular thing. So like 3 to the second power. So 3 to the second power gives you 9. So that's taking a log and write it in exponential form. Kind of like here, base of 8 raised to the 0 power equals 1. 5 to the negative second gets you 1 over 25. Okay, which they're all true statements. So here, if I'm going like this, I actually fill out this number last. Log the base. So the base up here is right here, the 4, and the exponent goes right there. So well, the only number left would be right there, 16. So 4 squared gets you 16. So log base 2 will give you 3. Well, what's the number? 8. Okay, log base 2, little 2 here, okay, equals negative 3. It's 1 over 8. And that's going from exponential to log. Okay, some properties of log. Log base of 1 is always 0. That makes sense because whatever the base is to the 0 power is always 1. If you're taking log base b to the same base b, it's going to be equal to 1 as well. On your calculator, there's 2 logs. There is a common log, which is log base 10, and that's just abbreviated by the letter log right there. So I know it doesn't have a number, but it's log base 10. No, that's right there. Okay. And then the other one would be a natural log. That's log base e, that Euler number we just learned. So it's kind of crazy. It's actually abbreviated ln. It's kind of a Greek thing or a Latin thing. So 2 commonly one user on your calculator. So a lot of these we're going to try to evaluate without a calculator. We're going to do it by hand. So I've got basically this question. 4 to what power gives you 64? And that would be the answer to log base 4 of 64. Well, 4 to the third power. Okay, so 1/4 raised to what power gives you 256. Now, we've got ourselves a fraction. Okay, so how to make this fraction flip? Well, I know that means my exponent's going to be negative. So then it's 4 to what power gives me 256, and I believe that's, if I break this down, 256 goes into 25, 4 times, so 6, 16, just kidding. What? A little tired. Yeah, 464. For crying out loud. Divide that by 4. That's going to give you 16. That's going to give you 4. And that's going to give you 4. So 4. So negative 4th power. Okay. 2 to what power gives you 1/8? Again, got to be a negative exponent. Okay, and that flips over to give you 8. So it's got to be negative 3. Now this one's a little bit tricky. So 32 to going to give you 2. So I need to shrink it. So in other words, it's going to be a fraction of 1 over something because it's going to turn into some sort of root. So 32 is made up of 2, 16, 2, 8, 2, 4, 2, and 2. There's 1, 2, 3, 4, 5 2s. So 1/5 power. Okay, I got a calculator here. So here, log base 10 of 7. So you should be able to find that log base 10 on your calculator. Go with that and actually get a number out of that. So 0.845, or the ln again on your calculator. 0.25. I lied. Oh, there we go. And that's going to be negative 1.38. Okay. So again, those are the only two you can do in your calculator. Inverses. And this is really how it works. So this is exponential base 10. This is log base 10. They'll cancel each other. You're left with just the 2. Okay. Log base 3, but 9's not a 3, so I'm going to make that 3 to the second power raised to x. So those cancel out, and you got 2x. Cool? All right, good. Log base 3. So I'm going to do inverse like we just got done doing. So Freaky Friday, x is equal to log base 3 of y. And I'm just going to rewrite this as exponential form. So here's my base 3 raised to the x power equals y. Makes sense because logs and exponential are inverses of each other. They're just going to have the same base of 3. Okay, so again, Freaky Friday, x equals log base 2 of y minus 1. But in order to break that out of the log, I'm going to have to write this as exponential. So there's my base. 2 to the x power equals y minus 1. Add 1. And I got 2 to the x plus 1 equals y. So exponential is the inverse of log. Kind of like this. We've got negative 2, negative 1, 0, 1, and 2. 1, 4, well here, 4, and reciprocal, 2, reciprocal, 1. X is all real numbers, and my y is bigger than 0. So negative 2 puts me at 1/4, 1/2, 1, 2, and 4. So there's my exponential growth. Now I'm going to use that to help me make an inverse by taking and flipping it around. So all my y values here of 1/4, 1/2, 1, 2, and 4 will come over and become x values. And my x values of -2, -1, 0, 1, and 2 will become my y values. So be careful, it's still over 1/2, or 1/4 down 2, over 1/2 down 1, and I've got what looks like this. And that's the graph of log base 2. Now, my domain and range are also going to switch. Notice now my domain is all a bunch of positive numbers. So now x is bigger than 0. My range before had the inequality, right? Y is greater than 0. Well, now it's my domain that has the inequality. And my domain before for exponential had all real numbers. Now it's my range that's all real numbers. So everything kind of flip-flops Freaky Friday. In fact, I don't have a horizontal asymptote. I've now got a vertical asymptote at x is equal to, right there, 0. Okay, so notice I kept the same base of 2. Whatever it's in parentheses, x minus h, is going to move over 2. Okay, so then that's going to be the same exact looking graph, except for now I'm going to move it over to 2. So my asymptote's right there. And I've got something like this. Okay, where my domain's going to change a little bit because now x is bigger than 0. My range is y is all real numbers, and my asymptote is x is equal to 2. Okay, copy that down again. All right, so plus 3 outside of the parentheses. So it's going to move everything up to 3. So asymptote's going to stay the same. And I'm going to have a graph that just looks like this. Okay, so my domain is x is bigger than 0. My range is all real numbers, and my asymptote is still that y-axis, that x equals 0. So hopefully that helps. We'll try this again with different logs and different exponential growths as their inverse, and we will practice the logs and doing those by hand a lot here in class too.